My dear students, today I am going to discuss some questions in geometric progression. First question is the sum of an infinite geometric progression is 15 and the sum of the squares is 45. Find the series. Solution is let the first term of the GP is A and common ratio is R. Therefore, a plus ar square plus and so on to infinity is equals to 15. This implies a by 1 minus r is equals to 15. This is the equation 1. Yeah, this is given in the question that sum of an infinite GP is 15. And then when each term is squared, then it becomes a square plus a square r square plus a r square and r to the power 4 plus and so on to infinity, and that is equals to 45. This is also given. That means the sum of the squares is 45. It is given in the question. And in that case, this implies a square by 1 minus r square equals to 45. Now, squaring equation 1, we get a square by 1 minus r to the whole square equals to 225. Okay, and dividing equation 3 by equation 2. The equation 3 is this that we have got after squaring equation 1. What we have got, that is equation 3. That means a square by 1 minus r to the whole square equals to 225. This is equation 3. And this equation 3 is divided by equation 2. And then we get a square by 1 minus r to the whole square divided by a square by 1 minus r square equals to 225 by 45. This implies, and when this will be reciprocal, then a square and a square will be cancelled and 1 minus r square will come up, and then we will get 1 minus r square by 1 minus r to the whole square equals to, and 45 5 z 45 5 z 225. So we have got here 5 by 1. Now by criss-cross multiplication we get 1 minus r square equals to 5 into 1 minus 2r plus r square, and that is equals to 1 minus r square, and here bracket is removed. All these three terms are multiplied by 5, and then we get 5 minus 10r plus 5 r square. Now 1 minus r square, both these terms are brought to right side, then here it is left 0, and then we get here this r square will come this side, then it will be 5r square plus 1r square, it will be 6r square, and this one will come right side, so 5 minus 1 will be 4, and so we get here 6r square minus 10r plus 4 equals to 0. And here all these three terms are divisible by 2, that's why we divide by 2, and we get 3r square minus 5r plus 2 is equals to 0. Now by middle term factorization we factorize it, and then we get here 3r square minus 3r minus 2r plus 2 equals to 0. Arrowhead. Now here 3r will be taken common, and then 3r square divided by 3r, we will get here r, and 3r divided by 3r, we will get 1. So in the bracket r minus 1 is left, and here minus 2r and plus 2 both are divisible by 2, so 2 we are taking common, then in the bracket r minus 1 is left, that is equals to 0. And here in both these terms you find that r minus 1 is common, so r minus 1 we are taking common, so r minus 1 into 3r minus 2 equals to 0. And so if r minus 1 equals to 0, r will be 1, and if 3r minus 2 equals to 0, r will be 2 by 3. So we get r equals to 1 or 2 by 3. Now from equation 1 we get a equals to 15 into 1 minus r. So if r equals to 1 we are taking, then a value 0 will get, because 15 into 1 minus r. So 1 minus r, that means 1 minus 1 is 0, 0 into 15 is 15. So a equals to 0. And in that case, so each term of GP, geometric progression, is equal to 0, which is not possible. and hence r equals to 1 not possible. That means r equals to 1 is not a valid value. So this is discarded. And then another value when r equals to 2 by 3, a equals to, we get 15 into 1 minus 2 by 3, and that is equals to 15 into 1 by 3, and 3 5 are 15, so we get a equals to 15. And so the series will be 5 comma 10 by 3 comma 20 by 9, because this a value and r value we are putting in this first equation that we have got, a plus ar plus ar square plus and so on till infinity equals to 15. So in that we are getting the series. Now the second question is if x is the arithmetic mean am between y and z, y be the geometric mean gm between z and x, then z will be the harmonic mean hm between x and y. We have to prove it. So we suppose solution is, as x is arithmetic mean of y and z, so we can write therefore x equals to y plus z by 2. This is equation 1. As y is geometric mean of z and x, so y square equals to zx. This is second equation. And now from equation 1 we get 2x equals to y plus z. Yes, and now multiplying y both sides we get. That means here we are multiplying both sides, left and right both sides we are multiplying y. And then we are getting 2xy equals to y square plus 2z, yz. And now you know that y square equals to zx, and that's why in place of y square we are putting here zx. So we get 2xy equals to zx plus yz. And here z is common in both the terms, so z we are taking common, then z into x plus y is left. So here 2xy equals to z into x plus y, and therefore z is equals to 2xy by x plus y. And one thing you have to keep in mind, arithmetic mean equals to, suppose if a and b are two terms, then arithmetic mean equals to a plus b by 2. Geometric mean equals to square root under ab, and and harmonic mean is equals to 2ab by a plus b. And that only we have got here, z equals to 2xy by x plus y. So this implies z is harmonic mean of x and y as the series obtained by taking reciprocal of each term of an arithmetic progression is in harmonic progression. Hence proved. Thank you. If you like, please share and subscribe.